and welcome. My name is Nischal Pradhan and I'm studying in British College, BSc Computing, and I'm here to give a live demonstration of my final year project. The title of my project is Low Cost Smart Irrigation for Small Scale Farmers. Uh, as being a part of farmers family, I have issue a lot of problems which can be solved solve yeah solved through engineering as well as computing. Because I choose this final year project, smart irrigation. It will help me as well as my family, as well as my neighbors, because I belong from rural area, where all the peoples work as farmers. Uh, the main reason why I have chosen this project is that it helps to reduce time, and it helps overflow of water. It helps to reduce labor cost. So I have chosen this project. Now let me give you my hardwares. Here are my hardwares. This is soil moisture sensor, which is connected to ESP32 via jumbo wire. This is relay module, and this is DC pump. Now let me explain how does this work. At first, the soil moisture sensor detects the moisture in soil, and it gives to ESP32, and ESP32 defines whether to pump water or not. In ESP32, I have written a lot of codes regarding threshold to generate water pump automatically. If the threshold is below 30 degree, it automatically defines that the soil is dry, and it automatically gives an order to pump, to run it and to get irrigated. And after getting threshold below 60, which is more for crops, which is detected by this soil moisture sensor, and it gives to ESP32, and ESP32 asks motor to stop pumping. Now ESP32 soil moisture sensor and relay modules are connected through jumbo wires, and this soil moisture VCC is connected to 3v3 voltage, and there is AO and DO, which is connected to G35 and 34 respectively. After that, this relay module helps to operate pump automatically via code. And here are also three jumbo wires connected: VCC, GND and IN. VCC is also connected to 3.3 power supply here. GND is connected to GND, and IN is connected to G27. Now let's move to an application part. I have made a mobile application using Kotlin. Now you can see a dashboard over here, and you can see at the top there is dashboard with a seed growing image. After that, there is A to Z. This is a features that I have included, which translate everything into Nepali, because as I am being a native Nepali, which helps me to operate or use this application very easily, as well as for my family, as well as for my friends. It will help to use this application very easily. Down below you can see there is a soil moisture, there is, which is 0%. Deep down there is a plant profile. There are three types of crops, which they are tomato, cauliflower, pepper. As if tomato require over 40 to 70% threshold, as well as cauliflower need 45% to 75%. At last, pepper needs 35 to 65% of water threshold in soil. Down below there is a pump controller, as there are two options. One is automatic, as well as there is a manual way to operate pump. Down below there is a moisture history, which gives moisture history from previous uh, previous data. This is my mobile application. Now let's do a testing phase. As the weather condition now is not good, I don't have a wet, I don't have a dry soil. So let's try without soil. As you can see, it's in manual mode. The soil moisture is below 30%, but the pump is not working because it's in a manual mode. Now let's me convert it into a automatic mode. As you can see, the pump automatically run, because, and it automatically stop because the threshold uh, is more than 30%. As you can see, now the threshold is below 30%. The pump automatically run. Now let me dip into a wet soil, and the pump automatically turn off. You can see very clearly. Now let me try my another features, which let's control pump manually. As you can see, let me turn on pump manually. As you can see, it's running. Now let me off it using manual button. Now it's turned off. At the end, our smart project techno smart our smart irrigation project health technology, which helps to water plant automatically and smartly. It's automatically check soil moisture, and if it's needed to irrigate, it automatically turn on and turn off. As my mobile application is made in, which translate everything in Nepali, it helps a user to work mobile application easily. Thank you. Now let me explain the wire, jumper wire, which I have connected to my hardwares. From soil moisture sensor to ESP32, VCC is connected to 3v3, whereas GND is connected to GND. AO and DO is connected to GIPO 34 and 35 respectively. As you can see in my laptop screen, uh, there are my hardware as well as software. In My application is connected to my hardware through where ESP32 set a hotspot name smart irrigation setup which is connected to my mobile. It helps to connect my Android application to ESP32, and and my relay module is connected to ESP through VCC to 3v3 pin and GND to GND and into GPIO 30 O27, and relay is connected to water pump. As you can see, extended V5 plus is directly connected to the power supply of V4 plus com relay, whereas no pump plus is directly connected to relay NO, and water pump is also connected to relay module. Now let me explain my code which I have done, which I have put, which I have written in Arduino IDE. Now let me explain some of my codes. As you can see, in line number of line number 11, you can see there is soil underscore AO 34, which define connection from soil sensor to ESP32 via pin number 34, as well as in line number 12 define connection to relay from ESP32 via pin number 27. Now let's move to line number 14 to 16. Over here, this is when the sensor is not connected to the ESP32, this shows a simulation. Now let's move to line number 34. Line number 34 is over here. This is the low threshold at line number 35. This is the highest threshold. Now let's move to line number 43 to 52. This is a sensor logic. Now let's move to line number 56. Line number 56, you can see over here. This is a calibration value of the soil. From line number 61 to 64, this helps to show that the pump is on. And in line number 92, from line number 92 to 110, over here, this helps data handling. Beside that, line number 11, 111 to 124, this define pump handling. At line number 132, line number 140, 46 is a threshold. At the last, there is the line number 171 to 177. It is the hotspot credential. Thank you. पाँच मिनट को गयो. At the end, our smart project, our smart irrigation project health technology, which helps to water plant automatically and smartly. It's automatically check soil moisture, and if it's needed to irrigate, it automatically turn on and turn off. As my mobile application is made in which translate everything in Nepali, it helps a user to